Hi educators, I'm excited to share another awesome Patchr lesson with you, and this one is called Wave Explorer Speaker. In the Wave Explorer Speaker lesson, we are challenged to create a printed circuit board or PCB that lets us turn the volume up to 11 as we create our own mini speakers. Through this lesson, students get hands-on with a lot of different electronic components as we create our own custom printed circuit boards, but we're also getting a greater understanding of real-world hardware design as we're challenged to create our own little mini amplifier circuits through prototyping methods in combination with our electronic design skills. As always, there are endless possibilities with what you and your students can create, but through Patchr's unique design interface and lesson resources, students of all learning levels will be able to find success. Let's get started. After launching the Wave Explorer Speaker lesson through Patchr.io, we are guided through the fundamentals of how the project actually works by using an LM386 integrated circuit, as well as a series of capacitors, potentiometers, and an audio input jack to create our own custom circuit board, all which outputs to a mini speaker. And as always, we're guided through the stages of this lesson by the Patchr teaching assistant known as Squidly. Squidly just keeps us on track, encourages us to keep going, and lets us know when we may have run into a problem in our designs. For the PCB board, you are provided with the sample shape that you're able to use throughout the lesson, but you can also draw your own board shape right in the Patchr Design Studio, or even upload a vector outline in SVG format that can act as your board shapes. These types of shapes and board designs can be created in a lot of different programs that are suitable for students of all levels like Tinkercad, Google Drawings, or Inkscape. So it's up to the educator to decide the detailed constraints of the lesson and design challenge, but we think it's an awesome extension activity to allow students to design and create their own unique board shapes as well. In the next stage of the lesson, we are guided through placing our components onto our PCB board. For the Wave Explorer lesson, this includes key components to make the circuit function properly, including our LM386 IC, 2 capacitors, a potentiometer, input jack, switch, resistor, and barrel connector. As we lay out our board, a ghosted image helps us ensure that the components aren't too close to the edge of our board or overlapping, as this could cause potential problems in the manufacturing stages. While this tool is there to help students who may be unfamiliar with PCB design find success, they do not need to use it, as students have the ability to design and lay out their board however they see fit. And don't worry, Squidly always checks our progress and will let us know if we've made any mistakes. This goes for custom PCB board shapes as well. After laying out our components, we need to create the circuit by routing the paths between them using the tracing tool. The guidelines can be used to help ensure we find success in this crucial stage of the design process, but there's usually more than one correct way to route a path. Again, students are challenged to design their own unique circuit boards based on their own shapes and innovative designs. Lastly, we have the chance to customize our board through unique graphics and designs in our silkscreen layer. Students can add their own names or title of the project, or even a personalized design to enhance their PCB creations. Once done, we finish our board and send it to fabrication. You'll receive your Wave Explorer PCBs in a kit that includes all of the components you need to assemble your circuit. After signing back into Patchr, students will then have access to unique assembly instructions that will walk them through each step of this process. To assemble our circuits together, we need to solder them together, and soldering is the process of joining electronic components together using a filler metal that we call solder. Soldering is a really important skill that we need to have if we want to create our own custom electronic circuits, and through this lesson, students will do just that as they gain greater understanding and skills in soldering while they create their own mini speaker. For students who are entirely new to soldering, we recommend checking out our Learn to Solder resource guide and introductory design challenge, as well as referencing the guide provided with each Wave Explorer lesson. As we assemble our speaker circuits, there are a few strategies that can be used to assist in the assembly process. The assembly guide walks us through assembling components based on size, which allows us to continue to lay the board flat on our workspace for easier assembly. Polar components such as the IC, capacitor, and connectors have a positive and negative connection. If we do not connect our polar components correctly, the current will not be able to flow through our circuit. Looking at our board, we can see square holes, which are typically for the negative connection of a component, and round holes, which are typically for the positive connection or for components with no polarity. Our silkscreen mask also helps us align these components correctly, as we can match the component features or stripes with the graphics printed on each PCB. Once assembled, we can test out our circuits. After using the barrel connector to connect to a power source, we can turn on our speakers by using the switch. Then plug in any device with a standard headphone jack and crank it up. Pretty cool, right? But the lesson doesn't need to stop there. There are endless possibilities for this project. The students are not only challenged to create their own custom circuit boards, but also prototypes and hardware solutions around them. Through different prototyping methods, including computer-aided design or 3D printing, students can get hands-on as we fabricate custom electronics that are truly unique. Whether it be a keychain or mini amplifier, adding different materials, glue, or other crafting methods can increase the aesthetics and ergonomics of our prototype inventions. And we find that this also creates greater engagement and problem solving for students of all levels, while enabling them to truly create incredible inventions as well. Visit us at Patchr.io and start creating your own custom electronics today.